So this particular class we are going to discuss about the ideas when the objects are not, the objects are alike. Observe here. So till now whatever words we discussed, all the letters are different. If the same letters are there, how to find out the number of permutations? Let us take a word permutation, P, E, R. Here we have to find out the number of different words that can be formed by using the letters of the word permutation. But what happens here? This is T, another T is there. Repetition of the letters are there. Same letter is appearing 2 times. Then what to do? Okay, right. These, how many words can be formed by using the letters of the permutation? I don't know. I am assuming the number of words that can be formed by using the letters of the word permutation is equal to, say, X words are possible. Among those X possibilities, this is one of the possibilities. Total X possibilities are there. Among those X possibilities, this one is the one of the possibility. Now, what I am doing is, these 2 letters are not different. These 2 letters are not different. They are distinct. Let us say this one as T1 and this one as T2. Right? Now, this one permutation gives, this is one arrangement gives us 2 factorial arrangements when these 2 different letters are interchanged. Right? So this is one of the arrangement. This T1 is keeping here, T2 is keeping here. T1 and T2 are interchanging. So this one permutation gives us a 2 factorial different arrangement if you consider T1, T2 are different. These 2 letters are different. But 1 is giving 2 factorial different arrangement. But 1 is giving 2 factorial means we are saying total X possibilities. So that X will give X into 2 factorial arrangements. But these are total how many letters? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. With these 11 letters, because all are different. With these 11 letters, how many words can be formed? 11 factorial words can be formed. But that is, we got X into 2 factorial. Therefore, you will get X is equals to 11 factorial divided by 2 factorial. So that's why whenever letters or words in a word, letters are repeating, we have to divide with those many times repeating. So that's why 11 factorial divided by T is repeating 2 times. That's why we are writing 2 factorial. That's why here total there are n distinct objects are there, n objects are there. Out of these n objects, P objects are alike of one kind, Q objects are alike of second kind. Then the number of different arrangements is equals to n factorial divided by P factorial into Q factorial. If there are n objects, out of those n objects, P objects are alike of one kind, they are all same of one kind. Q objects are alike of another kind. The number of different arrangements is equals to n factorial divided by P factorial into Q factorial. Suppose you see the word given like this, Mississippi. Total how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters are there. So they can be arranged in 11 factorial by I is there 4 times, that's why 4 factorial. S is there 4 times, that's why 4 factorial. P is there 2 times, that's why 2 factorial. These many different words can be formed by using the letters of the word Mississippi. Here he is asking the number of words. so that all S's do not come together. All S's do not come together. First of all, I am considering all S's come together. M, I, yes, 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 yes. All these S's we are considering as one unit. I, next also I, P, P, I. The number of different words that all S's do not come together. I am finding number of different arrangement that S's come together. So that's why all these S's considered as one unit. 1, 2, 3, 4, 5, 6, 7, 8. They can be arranged in 8 factorial by I is there 4 times, that's why 4 factorial. P is there 2 times, that's why 2 factorial. Into these 4 letters can be arranged among themselves in 4 factorial because they are identical, that's why again 4 factorial. So this is the answer for number of arrangements that all S's come together. But he is asking number of arrangement that all S's do not come together. From total number of arrangements S's come together, subtract minus 8 factorial divided by 4 factorial into 2 factorial. That is the answer for number of arrangements that all S's do not come together. So again he is asking number of arrangements so that no 2 S's occur together. No 2 S's occur together. In that case, what to do? First of all, M, I, P, P, I. So 1, 2, 3, 4, 5, 6, 7. Now these 7 letters can be arranged in 7 factorial by 4 factorial into 2 factorial ways. These 7 letters can be arranged in these many ways. Now these are the gaps. In these gaps you can fill. In these gaps you can fill S's. How many gaps are there? Total 1, 2, 3, 4, 5, 6, 7, 8 gaps are there. These 8 gaps can be filled with 4 S's in 8P 4 ways, but they are identical. That's why by 4 factorial. 8 gaps can be filled with 4 S's in 8P 4 ways because they are identical. That's why 4 factorial. Okay, so that is the way of answering that particular question. The first one we discussed the number of different words. This is the answer. Next we discussed the number of words so that all S's come together. This is the answer. All S's come together. Next we are discussing the number of words so that all S's do not come together. That's why from total number of possibilities minus S's come together we subtracted. Next one is no 2 S's come together. This is the case where no 2 S's come together. So this is the another question he is asking to do. He is asking assassination. The word is given as assassination. He is asking number of words. Number of words means 1. A is there how many times? A is there 3 times. S is there 4 times. Yes. I is there 2 times. Next, N is there 2 times. Remaining letters are different. What are those? T is there, O is there. Total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here also 7 plus 2, 9 plus 2, 11 plus 2, 13. So number of different words is equals to 13 factorial divided by A is there 3 times, that's why 3 factorial. S is there 4 times, that's why 4 factorial. I is there 2 times, that's why 2 factorial. n is there 2 times, that's why 2 factorial. That is the answer for number of different words. Suppose he is asking to find the number of different words so that i's come together or a's come together. A's come together means we have to consider all these a's as one unit. Now one unit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. Those 11 units can be arranged in 11 factorial by s is there 4 times, that's why 4 factorial. I is there 2 times, that's why 2 factorial. N is there 2 times, that's why 2 factorial. Into these can interchange their places in 3 factorial divided by 3 factorial ways, that is only 1. So this is the answer for number of arrangement that all a's come together. Suppose he is asking number of different arrangements so that all a's do not come together. All a's do not come together means this minus this one. Next he is asking no two a's come together. No two a's come together means yes, 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 I, n, n, t, o. Now these are the gaps to fill. So total how many gaps are there? Total we have 12 gaps are there. First of all arrange these. 11 letters can be arranged in 11 factorial divided by 4 factorial into 2 factorial into 2 factorial. After arranging these 11 letters, now we have 12 gaps are there. Those 12 gaps can be filled with the 3 a's in 12p3 because they are identical. That's why 3 factorial. Okay. So another question is there, permutations. The word is given as permutations. P, E, R. He is asking number of words that begin with P, end with S. Number of words that begin with P, end with S. Now remaining how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial divided by, what are the repetitions? Here we have T is repeating 2 times. There is no other repetition, right? So T is repeating 2 times. That's why we have to write 2 factorial. Okay. So next he is asking number of ways so that no two i's, number of vowels should come together. What are the vowels here? So E, U, I, O. Vowels come together. P, R, M is there. T, again T is there. N is there. S is there. Right? So he is saying vowels come together. That's why we have to consider all these vowels as one unit. Now 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8 units. They can be arranged in 8 factorial by T is there 2 times, that's why 2 factorial into, again these vowels can be arranged among themselves in how many ways? 4 factorial ways. So that is the answer for vowels come together. So there is another question he is asking. Between P and S, between P and S, there must be always 4 letters. Observe here, this is suppose here I am filling permutations, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Suppose here we are filling P, 1, 2, 3, 4 gaps, and here there must be S. Between P and S there must be 4 letters. Between P and S there must be 4 letters. Suppose in this place we are filling P, then we have to fill S here. Suppose here we are filling P, then we have to fill S here. Suppose here we are filling P, then we have to fill S here. Suppose this place we filled with P, then we have to fill S here. Suppose this place we are filling with P, then we have to fill S here. Suppose we are filling P here, then we have to fill S here. He is saying between P and S there must be 4 letters, right? Okay, suppose P is filled here, S is filled there, right? Now remaining how many are there? So remaining letters we have these. Total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They can be arranged in 10 factorial divided by T is there 2 times. That's why 2 factorial. Right? So between P and S there must be 4 letters. Yes. Now 4 gaps are there. So remaining 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places can be filled in 10 factorial by 2 factorial ways in this case. For these type of cases, how many are there? 1, 2, 3, 4, 5, 6, 7 are there. That's why into 7. In every case, the same you will get. Between P and S, there will be 4 letters. Okay. So that is the way of proceeding this particular question. So next class, we will try to discuss a few more ideas. Before going to discuss the other idea, just last question you can observe. We have 6 plus symbols are there and 6 minus symbols are there. The number of different ways of arranging these 6 plus signs and 6 minus signs, right? So that they come alternately. They have to come alternately. So how many ways we can fill those 6 plus signs and 6 minus signs? First of all, we have to fill 6 plus symbols plus 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 plus. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. 6 plus signs and 6 minus signs we have to arrange in such a way so that no 2 minus signs occur together. No 2 minus symbols occur together. Okay, 6 plus symbols can be arranged in how many ways? 6 factorial divided by 6 factorial. There is only one way. There is only one way. See, 6 plus symbols we arranged. Now, these are the gaps. In these gaps, we have to fill minus symbols. How many gaps are there? 7 gaps. 7 gaps we have to fill with the 6 symbols in 7p 6 ways. 7p 6 ways. Now those are all identical or not? That's why divide with 6 factorial. So 7p 6 by 6 factorial is the answer for that particular question. Okay. Bye bye.